This video is about the FOD generation, and in specific I want to talk about the Fermi-orbital descriptor Monte Carlo code, or fodMC for short. The fodMC has been described in one of our recent publications called The Interpretation and Automatic Generation of Fermi-orbital Descriptors. While in this paper we describe several methods to generate FOD positions, like a method based on the center of mass of orbital densities or an electron force field, in this video I will solely talk about the fodMC. The fodMC is available at GitHub under open source license. The easiest way to install it is via pip3 install fodMC. Or you can also git clone the repository and then install the fodMC locally. The fodMC can generate FODs for any given molecule. It does so by forming bond and lone FODs based on chemical intuition, giving us our valence FODs. On the other hand, the core FODs are well described by structural motifs, and the idea of the fodMC is to optimize the orientation of these motifs with respect to the valence FODs using Monte Carlo. In the end, we get all the FODs of our molecule. To illustrate this process, I'd like to take you inside the H2S molecule with its atoms and its FODs shown over here. In yellow we have the sulfur atom, and in white we have the hydrogen atoms. All the other points are FOD positions. As a reminder, the FODs for spin up and spin down are at the same position, so what you actually see are pairs of FODs. Now the very first thing that happens in the fodMC is the generation of bond FODs. That is the distribution of FODs between the atoms. And we do this according to the FOD bond order we provide. For H2S we have single bonds between the sulfur and the hydrogen, which are characterized by a pair of up and down FODs right in between these atoms on the bond axis. The starting point is typically the center right in between the atoms. Only for bonds where we have hydrogen atoms, we place the FODs closer to the hydrogen atoms. This comes from experience of previous FLO-SIC calculations. For multiple bonds, we use the same concept. Given the center between the atoms, we can place one pair above and one pair below this bond center, giving us a double bond. Or we can place three pairs of FODs in an equilateral triangle, giving us a triple bond. After generating the bond FODs, the fodMC continues to generate the non-bonded FODs, that is, the FODs in the non-bonded region, which are typically the lone pairs and the radicals. In our example, we have two pairs of up and down FODs in the non-bonded region for sulfur, corresponding to the two lone pairs. The generation of these lone FODs is similar to the one of the bond FODs. We find a point associated with the lone region of our atom, in this case sulfur, and orient our lone FODs around this point. In this particular example, we have one pair of up and down FODs above this point and one pair below it, and these two FODs are oriented perpendicular to the molecular plane. After this step, all valence FODs are available and the fodMC continues to generate core FODs. That is, distributing FODs in the core region. This is done by using structural motifs for the core FODs. In our example, we have one pair of up and down FODs at the nuclear side of sulfur, which correspond to the 1s orbitals. These are not shown here right now. And we have 4 pairs of up and down FODs in the 2s 2p shell. These FODs are oriented in a tetrahedron. So what's happening in the FODMC is that we introduce this tetrahedron and then rotate it with respect to all the valence FODs. This is done by minimizing their mutual Coulomb repulsion, assuming the FODs to be point charges. After this step is done, all FODs of the molecule are available. In summary, the FLO-SIC needs the nuclear species, the nuclear positions, and the bonding information as input. You can obtain these either from 3D mole files, which you can download from ChemSpider, or you provide this information by hand. The next crucial step is to double check your bonding information. For many molecules, there is more than one bonding pattern possible, and the FODMC will only generate the bond pattern you provide. You can then run the FODMC. This is easiest with the Python interface, and obtain the entire electronic geometry as defined by the FODs. To run the FODMC, you can use a simple Python script as shown here. First of all, we import the Python module of the FODMC called pyFODMC, and from that we import the mole to FODMC function, which transforms the information of a mole file into FODMC input. We also import the timing function. We then define our molecule, in this case H2S, and transform the information of the corresponding mole file into FODMC input. We then start a timing and generate the guess using the FODMC, which is one line of code. We end our timing and print how long it took the FODMC to generate the guess for this molecule. In this case, it takes about 0.1 seconds. I want to talk a bit more about bonding information and how we can modify it in the FODMC. For that, on the left-hand side, I show the contents of a mole file, and on the right-hand side, the contents of a so-called system file, which is given in the FODMC format. Now in the mole file, we get the number of atoms and the number of atomic species, the atomic coordinates and the corresponding species, and it tells us that between atom 1 and atom 2 we have a single bond, and between atom 1 and atom 3 we have a single bond. The exact same information is given over here, where we have 3 atoms, the atomic coordinates are given in angstrom, and we also specified that we want to place the 1s FODs exactly at the nuclear sites. We then provide the atomic species and the coordinates. And after this comment line, we provide the bonding information and the lone pair information. The logic here is that in the first parentheses, we provide the indices of the 2 atoms in that bond. And in the second parentheses, we have the number of up and down FODs corresponding to this bond. In this particular case, these are both 1, which provide us with exactly the single bond we want to have. Also, specifying lone FODs is done by providing the atomic index and in parentheses the number of up and down FODs in the lone region. In general, the FODMC generates single bonds automatically, so you as a user do not have to worry about it. And also the lone FODs are generated automatically, but you should always check that the generated guess makes sense. As always, I would like you to stay tuned. We are available at Twitter and at ResearchGate, where we update the current progress of this OpenSIC project. And we also upload videos on YouTube. And with that, I would like to thank you very much for your attention.